Okay, so we're going to get into logarithms and logarithmic functions, which in a way are connected to exponentials. So we know that 2 squared is equal to 4, 2 to the third is equal to 8, 2 to the fourth is equal to 16. And if I had an exponential function, something here, 2 raised to the x is equal to 32, you would be able to figure out what x is because this is a perfect root and the x would be equal to 5. But what we wouldn't know is if I had 2 raised to the x is equal to 12. And something like this is where logarithms are used. When you have an exponential function, a logarithmic function is really an exponential function. Um, so I would know that x is between 8 and 16 because 12 is between, x is between 3 and 4 because 12 is between 8 and 16. But just because 12 is halfway between 8 and 16 doesn't mean that x is 3.5. Okay? The way that logarithms are used is this formula. If you have an exponential function like this, b raised to the y equals x, it can be written in log form as log base b of x equals y. And these are two different forms, exponential form and log form. And I use a little saying to go back and forth. And I like this saying because it works going from exponential form to log form or from log to exponential. The first step is keep the base. The base of the exponent is the base of the log. And this base on the log is written in subscript slightly lower. You should always be aware that that is lower than the word log and lower than anything else here. And that expresses the base of the log. And it's going to be the same as the base of the exponent, what's being raised to that exponent. So keep the base, then go away. So what's going to come next? If I'm going from exponential form to log form, keep the base, then go away. Log base b of x, then come back is equal to y. So keep the base, then go away, then come back. And it works going from log to exponential as well. You keep the base, b, then go away, raise to the y, then come back equals x. So this is a log equation that I'm going to write in exponential form. So I'm just going to use this little saying that I use, keep the base is 2, raise to the, then go away, raise to the third, then come back is equal to 8. And if you're writing this in from exponential to log, you can do the same thing. Keep the base, log base 2 of, go away, 8, come back is equal to 3. And it works going back and forth, which is why I like this little saying there. So you go ahead and try this one. Write this in exponential form. I'll give you 5 seconds. Pause it if you need to. So I have keep the base 4 raised to the negative 4 is equal to 1 over 256. And because this exponent's negative, which is why that moves to the denominator, and it's really 1 over 4 to the fourth, which becomes 256. So if you remember that saying, you should be good going quickly from one to the other, back and forth either way. Say it all at once. Ready? Keep the base, then go away, then come back.
Keep it. Then go away. Then come back.
High fives. Keep the base, then go away, then come back.
Keep the base. Then go away. And then come back.
High fives. That was perfect. So go ahead and try these two to write in log form. Remember, it's the same saying. Keep the base, then go away, then come back. So I have log base 15, keep the base, then go away of 3375, come back is equal to the exponent 3. And the same here, keep the base, log base 4 of go away 2 is equal to come back 1/2. Okay, so we're going to evaluate the expression. So what that means is I'm trying to figure out what this is equal to. Well, basically, you can make it an equation. I'm trying to figure out what this is equal to. So when you're evaluating it, you're trying to figure out log base 3 of 243 is equal to x. What that really means is I'm saying 3 raised to what, or raised to x, is equal to 243. So go ahead and try to figure out what 3 raised to is equal to 243, and you've evaluated the log base 3 of 243. And that would mean x is equal to 5. Or if I have here, okay, if I'm evaluating the log base 3 of 81, that would mean I'm trying to figure out 3 raised to what is equal to 81, because I'm trying to figure out what this is equal to. So you've just done this one, so you should see that x is equal to 4 in this one. And what if I have something like this? So the base is 1/2 here, raised to what is equal to 256. That's evaluating this log, base 1/2 of 256. Well, the only possible way to get this fraction to equal a whole number like this is if I can get it flipped or get this denominator to come up to the numerator. And what can do that is if the exponent is, you are correct, negative. So what that means is the exponent is going to be negative, and so then I'm just trying to figure out 2 raised to negative x is equal to 256. Okay, so 2 raised to what is 256? I just know that it's going to be negative because it had to turn this fraction into that whole number, 256. And that would mean that x is going to equal -8. So you go ahead and try to do this one, log base 16 of 4. Go ahead and pause it for a second, think about it, and see what you can figure out. So you should have started out by saying 16 raised to what is equal to 4. 1, it's getting lower. You got to notice that. It doesn't mean it's a negative. A lot of people make a mistake, it's a negative. But a negative would move it into a fraction and move it to a denominator. But what can I do to 16 to equal 4 is take the square root. And you should notice a square root as an exponent is going to be 1/2. So 16 raised to the 1/2 means the same thing as the square root of 16, which would equal 4. So you would have 1/2 is what log base 16 of 4 is equal to. What did the rope say when it got tangled? Oh no, not again. Oh.